Okay, let's take a look at some absolute value translations. So we talked about how the translations directly correlate to the equation. So if we look at number one, it looks like the vertex of the parent function, which normally starts at 0, 0, was shifted over to the left 4 and down -3. So these are the transformations that occurred, which then means that the equation must be absolute value of x plus 4 minus 3. The plus 4 shows that it's shifted left because we do opposite of what our brain thinks, and the down -3 or the down 3 correlates to the -3 at the end. So what's inside correlates to going left and right and is opposite of what our brain thinks, and down 3 correlates to the -3 on the outside. So from here, the next one looks like it went down 2. So the equation should be absolute value of x with a -2 on the outside. The next one looks like it went to the right 4 and it went up 3. So right 4 up 3 is this equation, because right 4 correlates to a -4 on the inside and up 3 correlates to a +3 on the outside. And this one went left 4, down 4. So our equation should be absolute value of x plus 4 minus 4. Plus 4 to go left, minus 4 to go down. Then we're going to identify the key features. So for any absolute value function, the domain is all real numbers. For this one, the lowest y value is -3. So our range is greater than or equal to -3. Our vertex is at the coordinate -3, -3. Oops, sorry, -4, -3, because it went to the left 4. Our axis of symmetry is the vertical line running through the vertex. Since it's vertical, it's always going to be x equals, and the x coordinate is -4. As far as our increasing interval, if we had somebody walking on this graph, they would start increasing at this point, this piece of the graph. So starting at the x value of -4 until we get to infinity, which we can go through this way to get the symbol. If we just type the word infinity, it'll pop up for us. Clicking on it inserts it into, see, I did it twice, inserts it into the inequality for us. So then the next one starts decreasing at -infinity until we get to the -4, right? The start of this graph is decreasing, and the x values always start at -infinity. So our equation is going to be f of x equals absolute value of x plus 4 to show we went left, -3 to show we went down. So if you look at the vertex, it had gone left 4, that's where the +4 comes from, and down 3, that's where the -3 comes from. So this next one wants us to graph. So we're going to start by plotting the vertex first. Since it says +1, that means that this function had to go left 1 unit. And because it says 6 plus 6 at the end, that means that it had to go up 6. So our vertex is going to be at -1, 6. So let's plot that. -1, 6. I want to grab a point. I'll just move that out of the way. -1, -6 is right about here. And then to plot the rest of the points, we just go up 1 over 1 from the vertex in each direction. So I'm going to go in this direction, and I'm also going to go up 1 over 1 in this direction. It's hard to be exact on the computer, so it's okay if your points are off by a little bit, but essentially from the vertex, you should be going up 1 over 1, because for now, that's what our slope is going to be. And if you want, you can draw your lines. You can even put arrows on the end. Perfect. So our domain, and if you want, actually, you can even make them thicker. just different formatting things you can do. Cool. So this is going to be infinitely wide. So our domain is all real numbers. The lowest this graph goes is -6. So our range are y values greater than or equal to -6 for this one. Let's try one more graphing. So this one is telling us that it went right 4. The -4 on the inside tells us right 4. And the -3 at the end tells us that it went down 3. So our vertex is going to be at 4, -3. So we're going to take our point and go to 4, -3, right about here. And then again, our slope for now is going to be 1. So we're going to go up 1 over 1 in each direction to plot our next points. And again, I'm using a laptop, so the amount of control that I have over these points is not the best, but as long as we get the general idea of where our points are going, that's perfect. Again, I can even draw my line going through them, put a little arrow at the end, make it bigger if I want, to give our absolute value V shape that we like. So our domain for all absolute value functions is all real numbers, and the lowest y value we have comes from the vertex. The vertex has a y coordinate of -3, so my range is going to be greater than or equal to -3.